This is the screencast for section 5.1, example 6. Number 1 rule in solving trigonometric equations is you cannot cancel out an entire trig function, nor can you subtract out to zero out an entire trig function. Now I'll show you what I mean right here in example 6. Example 6 starts out with the cosine cubed of x over sine of x equals cotangent of x. Alright, so instead of just dividing both sides by cotangent of x, that's messy, I'm not going to do that. I'm going to subtract cotangent of x from both sides. So I have cosine cubed of x over sine of x minus cotangent of x equals 0. So I set the whole expression equal to 0 just like you would do if you had only x's in there and no trigonometry. So now the tricky part is I have to set aside a cosine over sine, which is a cotangent. Remember how when you're solving with a whole bunch of x's, the idea is to get everything factored so that each factored piece tells you what a zero would be? Well, same thing here. So I'm going to separate one cosine of x over sine of x, which is cotangent, and I'm going to push aside two of the cosines out of the cosine cubed. Now, each expression before and after the minus sign, each term, has a cotangent of x. So I'm going to factor out or undistribute that cotangent of x. So inside the parentheses, it would leave me with cosine squared of x minus 1. So either the cotangent of x has to equal 0, or the cosine squared of x minus 1 equals 0. One of those two terms in the factorization have to equal 0 for the whole thing to equal 0, the zero factor property. Let's see, cotangent of x is 0. Cotangent is cosine over sine, so when cosine is 0, cotangent is 0. That's going to be pi over 2 and 3 pi over 2. The directions say we only have to worry about angles between 0 and 2 pi, not including 2 pi. So we could go with this pattern forever, but we're not gonna. Now this one over here, cosine squared of x has to equal 1, so cosine of x can equal positive or negative 1, taking the square root of both sides. Cosine of x is going to be positive 1 at 0 and negative 1 at pi. So we actually have four answers. X can be 0, pi over 2, pi, and 3 pi over 2 to make this equation true. In exercise 51, the now try problem, this one is a little bit easier to see right off the bat. There is a cosine, it's already set equal to 0 for us, that's nice. There is a cosine in both the term before and after the subtraction sign, so I'm going to factor out a cosine of x. Leaves me with 2 sine of x minus 1 in the parentheses. So either the cosine of x is 0, or 2 times the sine of x minus 1 equals 0. Well, the cosine of x is 0 when x is pi over 2 and 3 pi over 2. So that one wasn't so bad. This one I'm going to have to do a little work. 2 times the sine of x equals 1 if I add 1 to both sides, and then divide by 2, the sine of x equals 1/2. Well, let's see, the sine of x. So what angles have the sine 1/2? This is kind of like inverse trig. Really, I'm trying to find x equals the inverse sine of 1/2. And that will be, let's see, I think pi over 6 and 5 pi over 6. Again, we're only worried about angles from 0 to 2 pi. So again, we have four solutions. We have pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2 in increasing order that will solve this function, or this equation.